Good morning, class. Alright, so I believe the rest of this section here, we're going to be dealing with what's called surface area and volume. The first thing we're going to target is surface area, and we're going to do surface area of each one of these figures. Notice how they're all listed here. The rectangular pyramid, the cone, the triangular prism, the hexagonal pyramid, the cylinder, the rectangular prism, the trapezoidal, the square pyramid, the pentagonal prism. You get the point. So, first thing we're going to do is surface area. If I take those two words apart, we're dealing with the outside of each one of these figures, or the area. Say you wanted to wrap each one of these in wrapping paper. How you would use surface area is how much wrapping paper do I use to cover each one of these. Okay? There is math to this, even though, I just buy the wrapping paper and I just wrap it. If it fits, it fits. If it doesn't, I'll just get more. But there is preciseness to this. So, each one of these has individual parts. These are all formulas, and these are formulas that I am going to give you, as you're going to see for today. Today's lesson is going to revolve around rectangular prisms or cubes. Actually, most of your prisms, like the triangular prism, the hexagonal prism, it's also going to revolve around cylinders and pyramids. And let's see, what is the other one we're going to do? We're going to do one more if I'm correct. Cones. So we're going to do surface area of those two. If you want to separate it into lessons, I'll go over 11.5, which are all the flat-based prisms, and then we'll go into pyramids and cones. Alright, here are the notes. So let's, one more detail about prisms. Prisms are defined by two bases, okay? And the bases are pretty much what tell you what kind of prism it is. So if you have, for instance, this first example, the rectangular prisms, well, it's going to look like either a cube or it's going to look like a box, pretty much. A rectangular box or a square box, whichever it is, those are called rectangular prisms, because any one of the bases is going to be some sort of rectangular cube. Now, if you look further down, where it says all other prisms, well, those are going to be defined by whatever the base is. Notice it has two parallel bases, and those parallel bases are triangles. So this would be a triangular prism. But if you look at like number 6 example right here, like which ones are these the bases? The bases are all the ones that are always parallel to each other. This right here, this trapezoid, and if I, let me change it, let me see if I can change the color of this one. And then this trapezoid back here, this would be a trapezoidal prism, or a trapezoid prism. I would understand that, and I would take that as an answer. So now that we have these two, and I'll turn the page in a minute. Notice each one comes with its own equation. They require, or at least a rectangular prism or cube require these guys: a length, a width, and a height. So if any of those are missing, you're going to have to find them. Because it's a rectangular prism or a cube, more than likely you're going to need the Pythagorean theorem. But if all three are given, then you simply use this equation and you plug it into the calculator. A lot of these are just going to be plug-in type of equations. You get the information, you write it out, and you plug it into your calculator, and bam, it's done. So let's look at number one. Number one is fairly easy, straight across. Here we have the length, the width, and the height. I know the question out there is, how do we know which one's the length, the width, and the height? If you have all three measurements, meaning you have this corner, and this one, I really don't care who you labeled width, length, or height. They're all going to be multiplied, which means the rule applies to all three of them. So you have your equation of 2 times the length and the width plus 2 times the length and the height plus 2 times the length the height and the width. Each one of these are filled in. You have the information. They broke it down into those pieces. I usually do that myself. And then all three of these are added. And you have your answer. You'll notice that on the homework assignments, when I post them, I've given you the answers. One more thing, and I'll put it on the post as well. Let's see, how many questions does this assignment have? 8. I'm cutting down your homework. I'll consider 13. So first 7 problems. And I'll put it on the actual post as well. How many problems I need you to do in the homework assignment. Alright, so it's not going to be the entire homework. Okay? And then I got a little surprise homework assignment, easy quiz grade. Won't be any problem at all. Alright, let's move on to the next example. Rectangular prisms are pretty straightforward. Unless you need me to really go over it, let me know in the private comments. I want to move on to the all other prisms. Alright, so here's key for all of the prisms. You need to pay attention to the actual equations that need to be used. The main one you want to pay attention to is that one, the surface area one. Okay, but it's a two-part. Okay, one, notice how it has 2 bases. Well, you're going to have to find the area of those 2 triangles, but because they're parallel and it's a prism, they're going to be the same. So you only need to find 1 base area, and then you multiply it times 2. The other one is you need to find the lateral area, which means you need to find these walls. 1, 2, and then the back one in the back. You need to find all 3 of those areas. So the easy equation is simply multiply the height times P, the perimeter. Okay, so as long as you know one of these pieces or all 3 of those, you can find that perimeter. That plus that will give you your perimeter. That will go with the same for any shape. It depends on what those 2 bases are. You'll just have to get the perimeter on those. So let's go to the first example, and let's make it hard for you. Let's go to number 5. Okay, so here we have 2 triangles that are parallel to each other, so this is a triangular prism. So I need to first find, well, in this case I want to label everything. Okay, I want to find the base of the area of the 2 bases, which means I only need to find 1. this triangle and the one in front of it both have a height of 4.1, and then this base right here is 12 because they're similar. So I'm going to find the base area by using the equation of a triangle, 1/2 base times height, and here is the base area for one of them. We're obviously going to multiply times 2. Now if we're looking at the actual triangle, here we have this guy right here. This is going to be my height. This is this edge. This is this edge. And this 12 is this edge. Hey, I can find my perimeter. If I add all three, 5 plus 12 plus 10, you're going to get 27. So I have my perimeter. I have my height. HP plus 2 capital B. Plug in. So now we move on to a trapezoid prism. Notice the two bases, the red one and the yellow one. Those are trapezoids. Guess what? I'm going to need to remember that the area of a trapezoid, because I need to find that base, at least one of them, is 1/2 base 1 plus base 2 times the height. So for this equation, the height is 12. The first base is 18. The second base is 23. So we plug each one of those in, and notice how it's used right there. Plugged in, and you have one base. So now we're looking at this figure. We know this distance right here is the same as this one, the same as that one, and the same as that one. This is our height for the prism. Now if I want to get the perimeter, then that means I need to find out how much this is, how much this is, how much this is, how much that one is. Well, it's 12 plus 23 plus, that guy's the same as that one, 20 plus 18. They're not going to give it to you on each one of the sides. You're going to have to look at the big picture. Add those three together and you get 73. So now we fill in the equation. The height of the prism times the perimeter plus 2 times the big B. Plug in. Alright, if we turn the page, there's another example of a trapezoid prism, another triangular prism. Number 7 is pretty straight across. You have to figure out the two trapezoids. Actually, you only need to get the area of one. They give you that height right there, they give you the two bases, so you can plug it into that equation, and boom, you have it. Get the perimeter. Well, you know this distance. You know that distance. You know this distance. And because, notice how this is congruent to this one, so this one is also over here. So you know that one too. So you have all four sides, you can figure out the perimeter. But let's check a problem like number 8. I won't be able to solve that perimeter until I find x. But lucky for us, we have a right triangle right there. So, it's safe to say we could use the Pythagorean theorem squared plus b squared equals c squared. This is the hypotenuse, so this guy's C, and they're using this as A, and this is B. So once you solve for x, at 17, you have your perimeter. So if you add all three, you add 17, 15, and 8, you get your perimeter. The other thing would be is to solve for the area of those two bases. So this is your base, this is your height for this triangle. Bam. 1/2 base times height. There's a reason why we did area formulas. Then it's just plug in the information. This is the height of the prism. Remember, the height of the prism is the distance between the two bases, between this base and this base. That's who he is. That is your height. The base, the height times the perimeter plus 2 times the big B. As we move further down, we're introducing cylinder. Again, I'm just introducing shapes, but I'm going to give you the equations to solve these. Okay, you just you have to just pick out or grab the parts that are missing. Okay, so for cylinder, and all of these take the same shape, the same form. You have to get the area of the basis and multiply them times 2. It's a type of this isn't a prism because there isn't any straight edges. It's a curved edge, so it's a cylinder. So you have to get the area of the two bases, the top one and the bottom one, and then you have to get the area that surrounds the entire cylinder. So once you get those, you add them together. Notice, two bases. So this is the two circles. Two circle area. And that is the lateral area. So what's important here is you need to get the radius for the circles, and you need to get this height. This is the height between bases. Alright, so let's look at example number 9. Let's look at the two circles. We're looking at the two bases. So 11 here is my radius. 26 is my height. Looks to see check, check. We have both. So let's put it over here. I know they do it straight off. They expect you to already memorize these equations. So the lateral, you can do it all at once. You can do them separate. You can do the lateral area first and then plug it in, or you can just do what they did right here. All they did was, alright, SA is my two bases, and area of a circle is just pi r squared. So I'm going to plug that in. Then I'm going to add what's called the lateral area, which is the area of just the tube, the around the tube part. Say it's a toilet paper roll. So to do that, they require 2 pi r times the height. So I have both sets of information. It's just 2 pi times 11 squared plus 2 pi times 11 times 26. So what they did was they simplified this. Okay. So 11 squared is 121, and then this becomes, I need a calculator, this becomes 2 pi times 286. These two multiply, leaving me with 242 pi plus 572 pi. This is just like you're working with variables. These are your variables. They both share the variable, so that means I can add those two numbers. I can have 528 pi. Well, what do I get when I do this? I'm okay if you leave it in terms of pi, perfect, but let's just say for pi, if you want to do it, I'm going to tell you pi is equal to 3.14. If you use the actual button that's on your calculator, or your phones do have access to the scientific calculator, so it'll have the symbol pi. I'm okay with you using it. Your answers will differ a little bit, but I'm only requiring you to use 3.14 for those of you that are going to ask me that question. So I would treat this like this: 528 times 3.14. The answer I'm going to get is 1657.92. Pause. Did you notice my mistake? Let's backtrack. I added wrong right there, and it shouldn't be 528. 572 plus 242 is actually 814. That's all I did. 814 pi. So it's 814 times 3.14. And that's why my answer differed. The answer should be 2,000. Well, if you used mine, 0.96. Notice how those two are slightly different. That one uses pi from the scientific calculator. I am going to understand if your answer is maybe 2 or 3 units off because of this. So do not worry that, oh no, I am not getting the exact same answer as the one that's on the homework assignment, because I'm now giving you the answers for the homework assignment, because I'd like for you to know, okay, this is the answer I should get. Okay, now if you're off by 100 points, just double check your work, because I could have made a mistake, but most of the time I think I did them correctly. You know, I'm not perfect, I'm just a normal human being, so if you do get it wrong, have me look at it. I'll retrace my steps, and if I find the mistake, perfect, I'll give you credit for it. But if not, that's the answer you should get. So if you get within 2 to 3 points, don't worry about it. You're doing it just fine. Alright, for number 10, barring that I make another stupid mistake like that, let's look at our information. Here we're given 15, we're given 9. I know this is my height. This is actually the diameter. But we already know that the radius is half of it. So the radius is going to be 7.5. The rest is simply plug into your equation. Two pi r squared plus 2 pi r. They took care of that. They brought it down to this. And then they used the scientific calculator to get this answer. Use 3.14. If you do that, you should get 777.15. That is using 3.14. So notice how they're somewhat close. Alright, I'm going to save this one and I'm going to move on to 11.6, dealing with pyramids.